There, we're good. 3, 2, 1. So systems with three variables, right? So we're talking about all this time now we've been doing two equations that have two variables, right? That's how all of our problems have been going so far, right? And we've used mostly X and Y, but in the word problem, sometimes we changed it up a bit. I'm trying to figure out how to make that. Oh, that's how I make that bigger. I just need to roll it. I don't need to. I was trying to be all crazy. But when we have systems where there's three variables, we have to have three equations. Each variable means I've got to have another equation when we're talking about solving things in a system. And really, what we were looking for when we were solving in a system is some common solution for them, right? Which played well for word problems, because if I had like 5 pounds of potatoes and 16 pounds of carrots and 2 pounds of apples or whatever, I could figure out the cost of like apples and potatoes and carrots, right? We could break it down because what was going to be common was their price point, right? And so we could use these different equations to come up with those price points. And we can do that with three variables as well. We just need one equation for each variable. It's basically like a double elimination, right? Before we were using elimination of a variable. In this sense, once we eliminate a variable, we're left with two variables, and then we can solve it like a regular system and then start plugging things in. Now, I know that's super wordy and super confusing because there's no numbers or anything in front of you just yet. And I promise you we're going to go through really detailed steps with it. But first, we're going to talk about the rules that are right in front of us, right? That won't make any sense until we see actual problems, but still, we'll talk our way through them. First rule says choose two equations. We have three equations, right? Because this is a system with three variables. So we're going to choose two in which you can easily eliminate one of the variables, right? We're going to call it equation A, right? We can call it equation 1, we can call it equation A, we can call it whatever we want. We're going to eliminate one of those variables. We're going to do whatever it takes to eliminate one of those variables. We're going to manipulate those two equations in one way to manipulate a variable. Then we are going to take one of the previous equations and match it up with the remaining equation that we didn't use. We're going to call that equation B. And we are going to eliminate the same variable we did from the first ones we chose. Then we can put those A and B's together, right? And we'll have two equations with two variables, and we are going to solve those like we would any two variable systems of equations. And then we're going to substitute our answer in to the others to figure out what the other variables equal. And now I know that sounds crazy, right? Like you can't even picture any of that in your head, but you will be able to once we work our way through it. Okay? I promise you that. Well, I can't promise you that. You actually have to be paying attention. Sometimes y'all aren't going to pay attention. I get it. It's morning. That's why I record it. So we're going to start with a problem. We're going to go, I'm not used to writing on this specific whiteboard yet, but we've got 2x minus 6y plus 9z equals negative 8. Three variables, right? So we're going to have two more equations on this for it to work. Our next one's going to be 5x plus y plus 2z equals, you see I have to put a line through my 0, it looks just like my 2, equals 10. And our third equation is going to be 3x plus y minus 8z equals negative 28. And so the first thing that we were told is to choose two of these equations where it's easy to eliminate a variable. Now, I say there's nothing we can't match up with either this equation or this equation because they have just a y for y. There's no numbers on them. Both of them are pretty easy to deal with. So I'm just going to take these first two equations right here, and I'm going to call them my equation A, right? So I'm going to go, okay, well, here's 2x minus 6y plus 9z equals negative 8. And then I've got 5x plus y plus 2z equals 10. And I want to eliminate one of the variables in these two equations. Which would be the easiest variable to eliminate? X, Y, or Z? Which one looks like it's got the least amount going on? X, Y, or Z? Yeah, exactly. Right? Y, that y in the second equation has nothing being multiplied to it, which means that I can just multiply that equation by 6, and it's going to eliminate that y variable when we add them together, right? Because here I have 6y, and here I have y. So if I just take this whole equation and I multiply it times 6, when I add these two equations together, the y's will drop out, which is what we're looking for. So here, I'm going to rewrite the top equation because we're not doing anything to it. So we're just going to leave it as is, minus 6y plus 9z equals negative 8. This one, though, I have to distribute this 6 through. And I'm using 6 because I have 6 on this upper y, so I need 6 on the bottom y. So when I add them together, the y's will disappear. 6 times 5x is 30x. 6 times y is just plus 6y. 6 times 2, well, that's plus 12z equals 6 times 10, which is 60. And when I add these two equations together, 2x plus 30x is just 32x. Minus 6y plus 6y, though, those y's cancel, and my y's have disappeared, right? 9 plus 12, well, that's plus 21z. Minus 8 plus 60 is 52. And notice now I have this equation in only two variables. I have 32x plus 21z equals 52, right? We know how to handle two variables, but we still need another two variable equation, right? So what we're going to do is we're going to take, say, this first problem and this last problem that we haven't done yet, and we're going to call this B, right? This was equation A that we did. Now we're going to have this equation B, and we're going to do the same thing using those two equations. We're going to eliminate the same variable, which is y, right? So I'm going to rewrite this. I'm going to rewrite the top one. I'm going to go 2x minus 6y plus 9z equals negative 8. And then I'm going to go, okay, we've got 3x plus y minus 8z equals negative 28. And I'm going to do the same thing that I did in that last problem. I'm going to eliminate that y variable. So I'm going to go ahead and I'm going to multiply this entire thing times 6. Top equation we're leaving alone because the only thing I need to do to make that y disappear is make that bottom equation a 6y, right? Because when I add the two equations together, right, minus 6y plus 6y just becomes 0 and our y's disappear. So again, I'm going to rewrite the top equation as though we've done nothing to it because we have done nothing to it. Plus 9z equals negative 8. But now we have to distribute this 6 through to each piece. 6 times 3 is 18x. 6 times y is going to be plus 6y, which is what we were going for the entire time, right? 6 times negative 8, well, that's negative 48. Let's see. And this, by the way, is 28, not 20. And 6 times negative 28, ugh, I have no idea what that equals. I do. It equals negative 168. So now when I add these two equations together, again, our y is going to disappear, right? So here I've got 2x plus 18x, that's going to be 20x. My y's minus 6y plus 6y is just 0, so we've eliminated y as a variable. 9z minus 48z, well, that's negative 39z equals minus 8 minus 168 means that I could just add those two together and give them a negative sign. I know it's going to be negative. That's going to be negative 176. So what I have now is I have two equations with the same two variables, right? And they are part of a system, which means that I can take these two equations, this 32x plus 21z equals 52, and this 20x minus 39z equals negative 176. And I can solve this system, right? Because it's just a two variable system now. And we've been working on solving those systems for like a couple weeks, right? So I have to look at how I'm going to be able to manipulate these equations so that I can eliminate one of the variables. And I'm just looking at my x's and my y's, I mean, my x's and my z's. And when I look at it, I go, okay, like 20 doesn't go into 32 evenly, right? Because 20 times 2 is 40. 21 doesn't go into 39. I am going to deal with x's because, I don't know, 32 and 20 seems easier to deal with than 21 and 39 because I know that 32 times 5 is going to give me something that ends in 0, and maybe 20 will go into that because it kind of does, trust me. I'm just trying to look at how I can get there the fastest, right? And there's certain things I can do. Like I can look at 20. Well, 20 times 2 is 40. 32 doesn't go into that. 20 times 3 is 60. 32 doesn't go into that. 20 times 4 is 80. Times 5 is 100. Times 6 is 120. And I believe what I'm looking for is 8. Like if I do 32 times 5, I think is 160, and 20 times 8 is 160. And I think I can work with those numbers. I expect you guys to use a calculator on this, right? If you don't know, like if you can't just figure out the numbers in your head. If I multiply this times 5, I'm going to get 160 right here. If I multiply this times negative 8, I'm going to get negative 160 here. And that's what I want to do. So we're going to go 5 times 32x is going to give me 160x. 5 times 21z is going to give me, I don't know, I have to look at my paper. I don't know what 5 times 21 is, but I think it's 105. But I'm going to look at my paper to make sure I'm right. Yeah, I am right. 105z. 52 times 5, I don't know what the heck that is off the top of my head. It is going to be 260. Do you get to use a calculator for this? Absolutely. You don't have to do all of this multiplication in your head. This is going to give me negative 160. It's why I made the 8 negative. It just, if I don't do it, it's okay. Then I just subtract the two problems, but then I have to remember to distribute that negative through to everything, and it's easier for me to just multiply it by the opposite number and already have those things lined up, whether or not they're positive or negative. 8 times negative 8 times negative 39, well, that's going to be a positive something, 312z. Our numbers are big, but we can handle big numbers, right? This is like 11th grade. We could do this. Then we have negative 8 times negative 176. I know it's going to be positive, and negative times a negative is a positive, and that is 1408. It doesn't matter that we've got these big numbers, right? All that matters is that that x is going to disappear, that we can see that we have 160x now minus 160x, right? Which means that our x is eliminated, right? And so what we're left here with is the 417z equals, let's see, we got 8, 6, 6, 1. And now we can easily solve this for z, because all we have to do is divide both sides by 417 and pray that that gives me some kind of a solid answer. And in this case, it does. It's going to give me z equals 4. So we are looking to find out what x is and y is and z is. And now I know that z is 4, right? Well, I have an equation right here, and I have an equation right here that only have two variables in them, right? They're x and they're z. I can pick either one of those equations and plug in the value for z and figure out what x is, right? So here I have, let's look at this one. We've got 20x minus 39z equals minus 176, right? So 20x minus 39z, well, we know that z is 4 equals negative 170. Oops, that is not a 7. 100 and, let's see if I can erase. 176. Well, 20 times x, 39 times 4, 40 times 4 is 160 minus 4 would be minus 156 equals minus 176. And I can add 156 to both sides. And I get 20x is equal to negative 20. And so we could see there that x is just going to be equal to negative 1, right? We divide that out, x equals negative 1. Well, look, now I know what x is, and I know what z is. The only thing I'm missing is y, right? So I have to go back to any one of these original equations that has an x, a y, and a z. So look at that top one. That top one looks pretty easy, right? Actually, the middle one looks the easiest, right? 5x minus y, but it doesn't matter. I can use any of the three original equations, and I can plug it in. Let's do it in a different color so it pops out. So if I have 2x minus 6y plus 9z equals negative 8. I know that x just equals 1, so it's 2 times negative 1 minus 6y, that's the one variable I don't know, plus 9 times z, which is 4, equals negative 8. And when we solve this, we'll know what our y value is. Right, so we've got 2 times negative 1, that's negative 2, minus 6y plus 36 equals negative 8. That's the same as saying minus 6y plus 34 equals negative 8. Right, I just combined the negative 2 and that 36. So I can subtract 34 from both sides. It helps if I write the 3 in. And I get minus 6y equals 34 and 8, 34, that's 2. That's going to give me negative 42. And when I divide both sides by negative 6, I get y equals 7. Once we have all of these, we know we're good. Is it a lot? Absolutely. It is a ton of work, right? It is labor intensive. None of the work is particularly difficult. The hardest part is making sure that you keep your steps in order. I was going to do like a bunch of other problems, but it doesn't look like we have time to do a bunch. But I do want to talk to you about the word problem version. And what I will do is when I finish solving all of these out on my notes, I will post my notes of all of my completed problems so that when you go to do your homework worksheet, you'll have samples of multiple different kinds of problems to work with. Okay? In the meantime, though, I want to at least give you one word problems so that you can kind of see how they set up. They're really similar to the word problems that I gave you before. The only difference is now we're going to have a third variable in them. And I'm just copying it down so I don't have to write all the words. Doing a little snipping tool there. WPSOE. So we're going to bring that word problem in really quickly. So here I have our little word problem. And we're talking about tickets. And I think we did one with tickets before. I can't remember fully. It says the theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission tickets, 2 senior citizen tickets, 3 child tickets, and paid blah, blah, blah. So it looks like our variables are going to have to be in what types of tickets that we have, right? So I'm going to go ahead and say that general admission we'll just call G. Right? General, we'll call G. We'll give it a variable of G. The other one is senior citizens. So we'll go seniors. We'll get super creative and we'll call it, we won't call it old people because O looks too much like a 0. So we'll call it S for senior, although that looks a little like my 5. So we'll have to distinguish between those two. And the other one is child. So we'll just call child the variable of C. And we know that Mark here, we know that he bought 9 G tickets, right? And he bought 2 senior citizen tickets, 2S, and 3 child tickets, right? And he paid a total of $170, right? That was Mark. And then who else do we have? We have Sarah. Sarah, let's see if she's forking out more than Mark. Sarah bought 5 G tickets, 4 S tickets, and 7 C tickets, right? 7 children's. And she spent $3 more than Mark. So right now, Sarah's the baller. Last but not least, well, maybe, I don't know, it could be least. No, it is least because that one only spent. We've got Kyle. Good old Kyle. Kyle went and bought what did he buy? Kyle bought 4 G tickets and he bought 1 senior citizen ticket. He doesn't like old people. And 6 children tickets, 6 child. And he spent $116.50, right? That pretty much sets up our equations for us, right? When we pull that information out, we pretty much have our equations written for us. So we don't have to look at the words at all anymore. All we have to really do is know that, what did I just do there? I have no idea how I did that. I was just trying to move the screen up out of the way a little bit. What do we know? We know we need to find out what G equals, what S equals, and what C equals. How much does each ticket cost? But our equations basically write themselves. We have 9 general admission plus 2 senior plus 3 child equals 170, right? And then we have Sarah's equation, which is 5G plus 4 seniors plus 7 children equals $173. And then we've got good old Kyle, who bought 4 general admission tickets plus 1 senior ticket. We don't normally write the 1 in, so I'm just going to write the S. Plus 6 children equals 116.50. And we need to figure out how much each ticket costs. That was me looking at the clock to make sure I could get it in there in time. And so all we have to do is follow that same process of elimination, right? We're going to eliminate, we're going to take 2 of the problems, we're going to eliminate 1 of the variables. So I'm going to take these 2 problems and I'm going to eliminate a variable. And then I'm going to take these 2 problems and eliminate that same variable, right? So my first one that I'm eliminating from, I'll do 9G plus 2S plus 3C equals 170, and 5G plus 4S plus 7C equals 173. And my other set, this is my A, right? We'll call that A, we'll call that B. This is my A equation. My B equation, I'm doing the same thing. I'm taking, that was a terrible looking B. I got like crazy with that. We're going to go 9G plus 2S plus 3C equals 170. And then the equation we didn't do, 4G plus S plus 6C equals 116.50. And then we're going to go, well, what do I have to do to these equations to eliminate one of the variables? I think S is the easiest variable to eliminate in both of these problems. Why do I think it's S? Because I know that if I multiply 2 times 2, I get 4. And here I know if I multiply 1 times 2, I get 2. So they're really easy to manipulate that S. On any of the other equations, I would have to mess with both equations to get something to eliminate, right? Like if I tried to eliminate C, I'd have to multiply the top equation times 7 and the bottom equation times 3 to get the C's to eliminate. This way I only have to manipulate one of the equations when I'm trying to get S eliminated, which is why I think it's the easier of the two. So to get this to eliminate, I'm just going to multiply this whole thing times -2. I picked negative because I have a positive 4s under here. When I add them together, I just want them to disappear, right? So minus 4s plus 4s is 0 s's, and that's why I use -2. So -2 times 9 is -18g. -2 times 2s is -4s, which is what we were going for. -2 times 3 is -6. C equals, oh shoot, 170 times -2 is, I don't know if I solved this one out. What is it? I think it's 340, but I want to make sure. Because I actually didn't solve these problems out yet. But it is okay. 170 is 340. But -340, right? Because we are multiplying times -2. And then this bottom equation, we just leave the same. So we can go 5g plus 4s plus 7c equals 173. And when I add these together, whoops, I get -13g. My s's disappear, which was the whole purpose of doing it, right? And then we get plus c, because -6 plus 7 is 1. And so we just have plus c equals, I don't know, 340 minus, I had a calculator here. I can't find what I did with it. I just have paper sitting on top of it. We got 170 minus 1, oh no, clear. We have minus 340 plus 173, and that gives us -167. And then we're going to do the same thing over here. We're going to multiply this equation to get rid of our s's. We're just going to multiply this times -2, and then we're going to have another 2 variable equation. I realize we're out of time. The bell just went off. I will finish this problem on a separate video. I'll do a couple of word problems on a video for you guys before the end of the day today so that you have this completed. But ultimately, it's going to work the same way. We're going to have another 2 variable equation. And we put those together and that's when we solve the system and plug them all in. Sorry that ran so long, but I told you it's like a lot of information. But I will make you guys a little video before I leave today so that you can